Hi everyone, warm welcome to today's webinar. My name is Anton Kardashov. I'm a solutions architect working for Amazon Web Services, and my prime focus is working with the public sector customers in the Central Eastern Europe region. Storage on AWS it's a really huge topic that we have a lot to cover, and today we'll go through the main storage services on AWS, and hopefully we'll have some time as well to discuss topics of data transfer and edge processing. So to start with, why choose AWS storage and why actually move to AWS? Obviously, the one of the main reasons is the pricing model is pay as you go. To give a bit of heads up for you, basically before, whenever you were planning your storage, your where to store and host your data, you needed to think about like the capex, the capital expenses, and buying hardware and software upfront. So basically, to plan it upfront, how big, how large your data center capability should be in terms of storage, and to provision this upfront. In AWS, you no longer need to do that. You only pay for what you use. Basically, you upload the data and you start paying for the data that you are being storing in the cloud. And moreover, you don't need to plan further. The more data you have, the more you can upload and store in AWS. It's almost limitless, as we say. So the terms like petabytes or exabyte are not really scary for us. Here, as I said already, we don't have many risks of capacity planning. So the more your business grows, no matter how rapidly it grows, you can store your data on AWS. Easy to use. It's really one single pane of glass. So you have a management console, you have SDKs, you have API calls that you can integrate with your current infrastructure landscape or your solutions and store your data and access your data as you please. Risk reduction in terms of durability and security of storage. We have up to date, we have 34 regions across the globe. And when we talk about durability, is that you can store your data not as a one single copy on one device. You can choose to store the redundant number of copies on one data center, meaning one availability zone within one region, or in all, like, for example, 3 availability zones within one region. So it means that your data will be distributed and stored securely on separate locations. If you want any further security and durability of your data, you can obviously copy or basically replicate your data to a different region, be it in Europe, in America, or for example in Asia. And with all of that, you can obviously reduce your time to market. So you no longer need to wait for your hardware and software to come to start making use of it. You just go today, this very minute, create an account, upload your data, and start using it for your business. About the global scale, I already said a few words. So let's talk about the topic of what exactly type of storage we have. So each storage option has a unique combination of performance, durability, cost, and interface. Of course, you know about block storage. It's raw storage, and data is organized as an array of unrelated blocks. The example of this are like hard disks, be it SSD or HDD, or the regular SAN storage arrays on-prem. The next type is the file storage, obviously presented as unrelated data blocks managed by a file server system. And the example of this type is NAS appliances, Windows file servers, NetApp ONTAP, and so on. And the cloud native solution, it's an object storage. Probably most of you heard about AWS S3, simple storage service, and it stores basically virtual containers that encapsulate your data attributes, metadata, and object IDs. and you use API calls or HTTP calls to access your data. The examples are SEP for OpenStack Swift. Next one. We offer a number of storage services that prioritize different characteristics. So it's a really good idea to prioritize when selecting the storage service for your project. We'll get into more details about this throughout the entire presentation, but let's stay on this slide for a couple of seconds and really understand the difference between or the main characteristics. First of all, durability and availability. And I know some people mix them up, but it's really important differentiation between the two. Durability is the measure of expected data loss, and probably you've heard of the famous 11 nines of durability for AWS. So it means that how many objects can be lost throughout the time. So for example, for Amazon S3, we advertise 11 nines of durability. That means that only one object out of 10 million stored on S3 could be lost within the time span of 10,000 years. So it's quite a durable solution. And availability, on the other hand, is the characteristics of how much time your system or your data is unavailable to access. So what is the expected measure of downtime? Be it 5 minutes, 1 hour, or 1 day. Security, the characteristic of security is obviously how do you handle the security for your data at rest or in transit? How do you encrypt your data? And where do you store the keys? Cost is also different. What's the cost unit? Is it only the cost per storing data, like dollar per gigabyte, or is also cost for accessing data, for example, with API calls? Scalability, obviously do you scale with the number of users, with the amount of data, and so on. And then performance metrics, it's bandwidth, it's throughput, it's IOPS, and so on. And integration, very important factor for the cloud services. How do your storage systems integrate with all the other services that are available, for example, in AWS or any other systems that you would like to integrate with? Moving on, is what we're exactly what I talked about, durability. So when you store 2 copies of your data on the one side in one building, basically it's designed for 99.99% durability, which is 4 nines. And on the right, we see the 11 nines of durability for S3 when we store the copies of your data in 3 availability zones, meaning like in 3 distributed data centers across one region. So basically, AWS has been helping customers on their cloud journey for almost 18 years now. And we help the customers like Netflix to build their entire infrastructure on AWS. So once again, Netflix is fully on AWS. Another example is General Electric. They moved around 9,000 applications from on-premises to AWS. So these are the example of huge systems that store their data on AWS. And moreover, it's not that we develop once and present the solution for you for the entire time span. It's the feedback from almost 2 decades of use at scale that actually drives 95% of our roadmap for our solutions. And we learned a lot, obviously. And I want to share some of the observations of adoption patterns we see, how customers have taken the cloud journey with storage. Let's talk about rehost first. These terms, and you see it on the left here. This typically is a lift and shift, where you take your workloads as they are, typically delivered on virtual machines, and migrated as is into AWS. It's also a good way for some quick wins. So whenever you don't want really to plan the re-architecting and refactoring the solution, you only want or you're aiming for quick wins, it's a good way to go. Then replatform means lifting an existing application to the cloud and adopting bits and pieces of it to the AWS platform to change your application. So in the database world example, you could spin up EC2 instance in a virtual machine, install MySQL database, and then migrate the database itself. However, you could also re-platform it by using the AWS RDS, relational database service, and let AWS manage the database for you. In the storage world, that means taking an existing application that depends on the underlying shared file system that on-prem can be a NAS or network attached storage server, and spinning up a EFS, Elastic File System, that can be a drop replacement for an application storage layer. A fully managed file system like EFS removes all of the provisioning and administration overhead of an on-prem product and lets you focus on migrating the application itself to the AWS cloud. And finally, re-architecting, which is building your application to take, for example, the full advantage of AWS cloud services. This also applies to any new application that you're writing or developing today. There is no reason you shouldn't be writing your new applications in the cloud. You get the advantages right from the start. So, but it's also like game changing for your existing business critical application. Many times this was used in a way to modernize your application that have been running for years. And here we have, as I said, AWS Cloud Native S3 object storage. So we are continuously expanding our portfolio of storage services. And to give a couple of examples here that you see, for example, on the right. So Amazon S3 Intelligent Tiering is an S3 storage class that automatically optimizes customer storage costs for data with unknown or changing access patterns by moving data to the most cost-effective storage tiers within the S3 service. One more example is the Amazon S3 Glacier Deep Archive. It's a storage class that delivers the lowest cost of any storage service and is at less than 1/10 of 1 cent per gigabyte per month. Another example, good one here for Amazon FSx and FSx for Lustre is a fully managed file system that is optimized for compute-intensive workloads such as HPC, high performance computing, machine learning, and also one more example is the media data processing workloads. Good. Let's move on, and we'll discuss each of the systems in details slightly later. So I just spoke to AWS offerings for object, file, and block storage, but it's just a portion of an AWS broad storage portfolio. For example, on the left, you see AWS Backup. It's a centralized backup service that provides a simple and cost-effective way to back up your application data across many AWS services. So it's not only the storage, it's also databases and so on. AWS Backup basically can automate backup scheduling and retention management. It provides a centralized way to configure and audit which resources are backed up in your AWS account, and the service also monitors backup activity to alert you as you need it. For on-premises, AWS Storage Gateway is a hybrid cloud storage service. Basically, gives you on-premises access to virtually unlimited cloud storage. Many customers would like to take advantage of the benefits of the cloud storage, but they have applications that are still running on premises that require the most active data to be cached locally. So you can use AWS Storage Gateway as a file storage or block storage target for this hybrid workloads. And this makes it basically easy for you to store all of your data durably in the cloud while keeping a copy of the active data set cached on the local gateway appliance. Then online file and object transfers, we have several options here. One is AWS Data Sync, which makes it simple and fast to move large amounts of data online between on-prem storage and Amazon S3, Amazon Elastic File System, EFS, or FSx for Windows, and so on. Data Sync can basically transfer hundreds of terabytes and millions of files at speeds that are up to 10 times faster than open source tools. And here another solution is AWS Transfer Family, which provides fully managed support for file transfers directly in and out of Amazon S3. Also, AWS Transfer Family supports SFTP protocols, FTP protocols over SSL, by the way, as well. So FTPS and as I said, the basic FTP. One more example here, which is quite important. If you have lower or restricted internet connection, or you simply cannot move the data online and you have a lot, like petabytes of data, you can leverage the AWS Snow family. So Snowcone, for example, is the smallest member of the Snow family, and it's portable. So you can imagine a metal bag with storage and some CPUs that will be shipped to your location. You connect it with a cable to your data center. You transfer there your data and you ship it back to AWS. In AWS, we take this device, we connect it to our racks, and transfer basically your data from this device to our data center, and you will see it in your AWS account. So that's the solution when you have a lot of data and you really have a limited bandwidth of your network connection. It starts from 80 terabytes. Basically, one device can be filled up to 80 terabytes. If you need more, obviously it can be scaled up. You can ask for 10 or 20 pieces of Snowcones. Cool. Let's move on. Let's move on to the block storage. And Amazon EBS, Elastic Block Store, is an easy to use, high performance block storage service for the use with our virtual machines with EC2 instances. EBS volumes attached to your EC2 instances, which means they persist independently from the life of your instance. So if an instance happens to go down or just being, let's say, restarted or terminated completely, your EBS volume remains alive. EBS is designed for quite a wide variety of workloads, which I will cover in the next slides. And you can use EBS to take advantage of the benefits of the cloud storage and scale both throughput and transaction intensive workloads for virtually almost any capacity. So EBS is quite reliable. Our architecture is built for mission critical applications, and EBS volumes are designed to protect against failures by replicating itself within availability zone, so within one data center, and it offers 5 nines of availability and is annual, and its annual failure rate is between 0.1 to 0.2%. So it's quite low. Finally, and it's very important here, EBS volumes are extremely secure. Overall, in general, in AWS, we treat security as a number one priority. So on top of the advanced key management and volume encryption options and features, we constantly look for new ways to innovate and make security easier and more robust for our customers. Recently, we announced the ability to encrypt newly created EBS volumes by default with a single basically setting in your account. So it's just one click of a button and your volume is encrypted, like even before creation. So EBS, as I said earlier, is an extremely versatile storage solution. And to give a couple of examples of solutions that it can be used for. For example, databases like SQL Server, Oracle, SAP, which are widely deployed on EBS. And so these are the example of the commercial databases, and EBS is also well suited for open source, relational and NoSQL databases like MySQL, PostgreSQL, Cassandra, MongoDB, CouchDB, for example, to name a few. EBS is also widely used for the workloads like big data analytics engines like Kafka, Splunk, Hadoop, also for data warehousing solutions. It's also used for file systems and media workflows, and for other enterprise applications like VMware, Microsoft SharePoint, for example, or Exchange. EBS is also widely used for containerized workloads. So basically your storage on your containers will be EBS volume. And it's also one of the use cases for EBS volumes is business continuity and disaster recovery. So basically you can replicate your data to EBS volumes. So to talk about some of the characteristics of EBS volumes, EBS delivers on all function levels, be it speed, simplicity, reliability, scalability, security, or cost. So, for example, SSD-backed IO2 volumes deliver up to 64,000 IOPS and 1,000 megabytes per second of throughput per each volume. And you can use multiple volumes for even greater performance, so up to, if I'm not mistaken, 80,000 IOPS, and don't quote me here, I'm not sure, but I think it's 1,750 megabytes per second of throughput per instance, but please don't quote me on this one. Yeah, to move on. So you have like a really high flexibility of volume selection. So for example, GP3 volumes provide IOPS performance for most workloads with predictable baseline and burst. So GP3, you see here the SSD. One important note here, we also still have the GP2, the previous version of GP3. And if you'd like to save some costs, we highly encourage you to migrate your data from GP2 to GP3 SSD disks, EBS volumes. Then IO1 and IO2, you see here again, IO2, the latest version of the SSD family. So IO1 and IO2 volumes are built for critical and IO, so input-output intensive workloads needed consistent and very high performance. And when we are moving to HDD, ST1 volumes are ideal for big data and analytics workloads that need really high consistent throughput. And SC1, for example, volumes are designed for rather colder throughput-oriented workloads with data that is infrequently accessed. Important note, we also have, so almost each EC2 instance comes with a so-called instance store. It provides a temporary block level storage for your instance. And this storage is located on disks that are physically attached to the host computer. So if you provision an EC2 instance, underneath there's obviously like a hardware and this disk that are physically attached to the host. And instance store is ideal for temporary storage of information that changes frequently, such as, for example, buffers, caches, scratch data, and some other temporary content that is not persistent. So to give you a perspective, whenever the instance is terminated, you will lose the data that is being stored on the instance store. Yeah, it's good for some caching, but I suggest you only use it when you can tolerate the data loss. Okay, moving on, shared file system, just check. And we'd start with Amazon EFS or Elastic File System. And our customers are using EFS for their shared storage needs when deploying their analytics and SaaS applications. And basically, EFS is a cloud-native file system built from the ground up, and it delivers virtually bottomless file storage that customers tell us that it works just fine, where they don't need any storage expert to manage the file data at any scale. So it really works just fine. It's the cloud native file system that was developed for the cloud native applications. So what it essentially is, EFS is designed to provide serverless, fully elastic file storage that lets you share file data without provisioning or managing storage capacity and performance. It can be used with AWS services and on-premise resources, and it's built to scale to actually petabytes on demand without disrupting any application performance. It's well suited for a large spectrum of use cases, from home directories to really business critical applications. And also the use cases include the storage for containers and serverless applications, for big data analytics, for web serving, for yes, for media and entertainment workflows as well. And also it can be good for database backups. Think about this as well. To say here something. So we can recap on the original topic of SaaS and analytics applications. So we heard a couple of customer examples that there is a wide variety of use case where customers are deploying their SaaS and analytics applications. So some of these examples include data science for genomics, for machine learning, telco billing, modern application with containers, serverless services, and all of these applications have been deployed on shared storage. So our customers tell us that they use EFS because of its ease of use, its elastic nature, and also because they need like the throughput, the low latency, and IOP of an elastic capacity and performance that EFS can basically deliver. So here the slide is more about like that it's basically it's elastic. So EFS is meeting the customer needs with its enhancements to fully elastic performance, and by really raising the bar on the throughput, on IOPS, and delivering the lower latency. EFS is serverless. As I said before, what do I mean by serverless? So basically the servers underneath, under the hood, are being encapsulated, and you don't care about provisioning the hardware and or virtual machines on how it works under the hood. So you don't need to provision or manage any infrastructure or capacity for EFS. You just have the solution as is. It can also be shared with up to tens of thousands of concurrent clients, no matter the type. And these could be the traditional EC2 instances, virtual machines, containers running on either your self-managed clusters or one of AWS container services like Amazon ECS, Elastic Container Service, or Amazon EKS, Elastic Kubernetes Service, and Fargate, the managed container service from AWS. And it can also be like a file storage for serverless function running on AWS Lambda. Our customers can also use EFS with our ML, AI and ML platform with Amazon SageMaker. So basically, while training their data, it can be stored on, and training their models, the data can be stored on EFS. And one more important point here is that you can access EFS file systems from on-prem via either VPN connection or AWS Direct Connect, which is a dedicated network line between you and our data center. Moving on, EFS offers 3 storage classes. It's EFS standard, which delivers a sub-millisecond latency performance. And it's designed basically for actively used data. So whenever you have the data that is being actively used by your applications or your users, it's standard storage class. Then the second one, EFS infrequent access, EFS IA, which is a cost optimized for data accessed more or less a few times a quarter. So whenever you have like more active usage, please consider standard storage class. And also the third one is EFS archive, which is a cost optimized for long-lived data accessed few times a year or even less. And you can see the pricing for different storage classes. It's basically the infrequent access is 95%, has 95% lower cost than the standard, and archival storage is a 50% more cost effective than even infrequent access. Cool. Let's move on to Amazon FSx. And FSx is basically a family of file systems that makes it easier and cost effective to launch and run popular, industry popular file systems that are fully managed by AWS. And Amazon FSx provides several file systems to choose from. It's FSx for Windows Server, for Windows File Server, sorry, for business applications, and Amazon FSx for Lustre, for compute intensive workloads. It can be Amazon FSx NetApp ONTAP, and Amazon FSx for ZOps. Amazon FSx for Windows File Server. It's again, as you are, if you're using Windows File Server, it's almost exactly as you're used to it, but it's a managed solution of coming from AWS. So here you have a flexibility of choosing between SSD or HDD disks, HDD or SSD storage option. You can create your file system for one single AZ storage, so meaning like your data will be stored within one data center, or it can be multi-AZ for redundancy and availability. You have the features as you have it on any Windows File Server for data deduplication, and you have the Windows native SMB protocol access. With FSX for Windows, you basically no longer have to worry about setting up and provisioning file servers and storage volumes, replicating data, installing file server software updates and patches, and managing failover and failback. And also one more important thing, you no longer need to manually perform the backups. Everything can be automated and set up natively on AWS. What's more important as well here, I talked a bit already about the integration. FSX is deeply integrated with other AWS services, and we start here with compute. We talked about ECS, EKS, Amazon EC2 instances, serverless Lambda, the virtual desktop solution from AWS, which is AppStream 2.0 or workspaces. Then security features, so role-based access with identity and access management, the keys, the security keys solution, which is Amazon KMS, where you can basically store and rotate your encryption keys. Also, you can spin up AWS directory service for managed Active Directory, for example, and integrate it with FSX for Windows and so on. For monitoring, you can also use our AWS cloud native tools, CloudWatch, CloudTrail, and obviously the data management part to transfer the data with data sync and configure automated backups with AWS Backup. Okay, to preserve the time a bit, let me please skip the FSX part and move to object storage, which is so. I skipped the FSX for Lustre and FSX for NetApp ONTAP, but let's move and really discuss the object store, which is Amazon S3. As I said before, S3 is the cloud native object storage solution from AWS. It delivers 11 nines of durability. So to remind you again, it's the expected loss of one object out of 10 million objects stored in S3 in the 10,000 years. It's really cost effective. So the pricing is 2.3 cents US dollar cents per gigabyte for the first 50 terabytes of data per month, and then it drops further to 2.2 cents per gigabyte and so on. So one of the quite amazing things about S3 is that there is a storage class for basically every workload, and it helps to tailor your cost so you meet all of the requirements for things like retrieval performance, for access frequency, access duration, but you don't pay any extra for characteristics that you don't need. So and the key here to optimize the S3 cost is to choose the right storage class. For example, S3 intelligent tiering is almost always the right choice here. That's because it's automatically moves data from warmer storage classes to colder, less expensive storage classes based on how frequently your objects are being accessed. If you simply want to set it and forget it and be confident that S3 is keeping your cost optimized, intelligent tiering is likely to be the really right choice for you. I would like also to mention Glacier Instant Retrieval. It's designed for rarely accessed data, but where it still needs millisecond retrieval performance. So you store your data that is not being accessed quite often, but in case you need this data real quick, that Glacier Instant Retrieval will be the option for you. And one more important point for this slide is that S3 Express One Zone. It's the recent development. It adds to our existing portfolio of storage classes, and yeah, it's basically for the fastest and most actively exit data, but it is stored in one availability zone only. Here we have another slide to basically deliver the details and characteristics for every S3 storage class. By the way, these slides will be distributed, so in case you missed any information or whatever, then you will find it in the slides. Okay, S3 gives you quite robust capabilities to manage access, cost, replication, and data protection. The thing like S3 access points makes it easy to manage data access with specific permissions for your application using like a shared data set. S3 replication manages the data replication within the region or to actually other regions. Some other features like S3 storage lens delivers like organization-wide visibility into object storage usage and its activity trends. And since S3 works with AWS Lambda, the serverless compute, you can log activities, define alerts, and automate workflows without managing any additional infrastructures. So it's our AWS Lambda serverless compute service that I can put and store the data directly integrated into S3. One more important feature that I wanted to mention is the S3 object Lambda, and you can add your own code to S3 GET requests to modify and process data as it's returned to an application. So can be useful for websites, for example, when they're hosting objects that are stored on S3, and you would like these objects to slightly be changed, for example, some data or take out some of the data from the object. So with Lambda and S3 GET request, you can do that. Then S3 access management and security. S3 has a deep integration with AWS Identity and Access Management Service, AWS IAM, for user access management. It has access control lists to make individual objects accessible only to authorized users. It has bucket policies to configure permissions for all objects within a single bucket. It has query string authentication for grant to grant time limited access to other users request with temporary URLs. So in case you would like to give access to some users to these or the other objects for only a limited time, you can have the query string authentication. S3 supports server-side and client-side encryption. Server-side with 3 different key management options. S3 inventory. With this feature, you can check the encryption status of your objects, whether all objects in one bucket are encrypted or only some of them. S3 block public access feature is basically a set of 4, as far as I remember, security controls to ensure that your S3 buckets and objects do not have any public access at all. And you can use Amazon Macie service to discover, classify, and protect sensitive data stored in your Amazon S3 buckets. A bit about some new features of S3. For example, mount point for Amazon S3 is like it's a new open source file client that delivers high throughput access. It lowers the compute cost for data lakes that have actually been designed on S3. And with mount point for Amazon S3, so it's basically a file client that translates the local file system API calls to S3 object API calls like get or list. And why is it useful? It's quite ideal for read-heavy data like workloads that process terabytes to petabytes of data, and these applications need S3's high elastic throughput to scale up and scale down across thousands of instances. Okay, yeah, one more quite an important thing. It's data exchange for S3. This service is helping customers to easily find, subscribe, and use third-party data files for faster time to, let's say, to analytics, to insights, to storage cost optimization, and it's helping the simplified data license management. So basically, if you have a data set that you would like to share with the world for usage, let's say the medical, so tokenized or anonymized medical data set that you would like to give access to different customers and universities for training their AI and machine learning models, you can do so with data exchange for S3, and you can also earn money for that. Good. Let's move on. We still have 5 minutes to go. Let's talk a bit about data transfer and edge processing. So data transfer. Once our customers have decided to move their data to the cloud, AWS offers 11, maybe now even more. I would need to double check the slide. 11 different ways to get data in, depending on the nature of the data and the application. So, for example, we have AWS Direct Connect, which is a private connection between an on-prem data center and AWS region. For streaming data, customers can use Kinesis Firehose to send the data in bulk. So in bulks, customers can use Snowball and Snowball Edge, as we discussed before, for the offline data transfer. AWS Data Sync, again, is a data transfer service that automates transferring and synchronizing data from on-prem NAS over the network to S3 and DFS, for example. And the speeds are like 10 times faster than any open source tools like rsync or Robocopy, for example. And for the companies that require SFTP or or FTPS to move their data, we have AWS Transfer Family. And basically, no matter the use case, we have a data transfer method that fits quite perfectly to any of the use cases. Let's focus a bit on the storage gateway. And storage gateway addresses the hybrid cloud storage challenges that our customers face. So a storage gateway allows customers to connect to and use the key cloud storage services like S3, S3 Glacier for our archival usage, and EBS. So additionally, storage gateway integrates with other AWS services like KMS for key management, IAM for identity and access management, CloudTrail for monitoring the access, and CloudWatch for general monitoring of workloads. Storage gateway can be easily deployed on-prem, either as a virtual machine, and here we support all the major hypervisors, VMware, Nutanix, you name it, or via the pre-configured hardware appliance that can be also bought from AWS. And by providing basically local cache, Storage Gateway enables low latency access to the frequently accessed data on premises. And Storage Gateway supports access via standard storage protocols like NFS, SMB, iSCSI, and iSCSI VTL for the tapes, and the data can be stored in Amazon S3. And here also no charges to basically customer applications. So you basically use Storage Gateway to connect to and store your data. A bit of context to Storage Gateway. So there are 4 types of that. It's the file gateway, S3 file gateway. It's a file interface that enables storing files and as objects on S3, and while still using the standards like NFS and SMB. And you can also access these files via NFS and SMB from your data center or from your virtual machines in AWS like EC2. Or you can also access these files as objects with an S3 API calls. Amazon FSx file gateway, it's basically optimizes the on-prem access to Windows file shares on Amazon FSx for Windows, and it makes basically it easy for users to access FSx for Windows file server data with low latency while still conserving shared bandwidth. Tape gateway. The tape gateway presents itself basically to your existing backup application as an iSCSI based virtual tape library or VTL. It consists of virtual media changer and virtual tape drives. So as like under the hood, it still uses the Amazon S3, but it virtualizes the access as and appears to be like as a virtual tape library. And one more thing is a volume gateway. It's like an application block storage volumes using iSCSI protocol, and data is written to the volumes. Can be asynchronously backed up as a point in time snapshot and stored in the cloud as EBS snapshots. So the difference here with the volumes, it's actually been stored as EBS volumes, not as an S3 object. We are out of time, so maybe I'll say one more thing about DataSync. It's an online data transfer service that basically simplifies, automates, and accelerates moving data. I already said it a couple of times before. It's 10 times like more performant than Robocopy, for example, and you can really use it to move your data into the cloud or within the cloud. Yeah, I'll stop here for any questions that you guys have in the round. Thanks again for listening and for your attention. If you have any questions, for example, you're interested in diving deeper in that or any other service for storage, please reach out to me. Please reach out to my colleagues at Mook. We will dedicate time to your use case and really have a deep dive with what you have. Again, thanks a lot for your attention, and I'm open to questions.